So this test is all about orbits and cosmic and space. So this quiz is all about orbits and cosmic and space. This will be the second half of your written question. There will be a couple of questions about moving around in a circle, either looking at a car going around a circle, friction is what's pushing it in a circle, or the gravitron ride, or what else did we look at? Roller coaster loop, which is on the Earth, like we did last lesson, or those, I think those, finding the normal force on a roller coaster or on a Ferris wheel. Those are the stuff that are on the ground. Otherwise, most of the written is going to be in outer space, because in my heart of hearts, I want to be an astronaut still. I'm still a little boy that way. Number 1. What is the orbital speed? Now, you may be able to get there with a shortcut. You might remember an equation, but I'll walk you through the entire procedure. I would say, am I in orbit? Yeah? Well, then gravity is what's pulling me in a circle. I know that gravity, am I in orbit? I can't use mg, because g up there is probably not 9.8. I have to use Newton's law of universal gravitation. Big G, big M, little m, over r squared, and that equals mv squared over r. Well, really what it equals is ma, because force equals force. Really, though, it's mac, because we're moving in a circle. I need to use a circular acceleration. And what you have on your formula sheet for this unit are only two equations, the v squared over r and the 4 pi squared r over t squared. But just remember, those are accelerations. Those aren't forces. You need to multiply by a mass to get a force. Little m cancels. One of the r's cancels. And I think we end up with orbital speed. This one is clean enough that I've started memorizing it in this unit. I think it was that. I'll forget it again in a month. The other ones with t and stuff by themselves, I'd still derive. Is that right? Yeah, that's the right equation, yeah? So it's going to be square root of 6.67 times 10 to the negative 11, the universal constant of gravitation all throughout the universe. Earth, yeah, 5.98 times 10 to the 24th. All over. Did they give me a radius or an altitude? So I don't need to add the radius of the Earth. I don't need to add 6.38 times 10 to the... I can just go to 10 to the 6. I can go straight to 8.1 times 10 to the 8th. Now, something's gone wonky on my boot up. Or is it going to work now? Maybe it will work. No. So I need to use this calculator, which I hate, but that's okay. 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th divided by 8.1 times 10 to the 8th. Square root of that. You get... Am I wrong? Is that, oh, is that right? 701? Okay. 702? Oh, you know why? That's a massive radius. We're because the radius of the Earth is 10 to the 6th. So we're 100 times the radius of the Earth. Yeah, we're out there ways. Sure, you don't have to go as fast when you're that far out there. That makes sense. 702 meters per second. If you got that 2 out of 2. Otherwise, I would give you a half mark if I saw you right. Gravity is what's pulling me in a circle. I would give you a half mark if I saw that. Half mark for the numbers and a half mark for the answer. Did anybody add the radius of the Earth to the R? Just read carefully. If it had said altitude, then I would have had to add the radius of the Earth. Although, honestly, that would hardly make a difference because that radius is so big, adding the radius of the Earth barely changes your answer at all because you're so far away already. What's the kinetic energy? Oh. Ke equals a half mv squared, a half 2500. I'm going to write 702, but you know I'm going to use my answer button, squared. Whatever answer you got there, if you dropped it down here and you squared it and then multiplied it, like I'll give you full marks, 2 out of 2 for that. 0.5 times 2500 times answer button squared, you get 6.16 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 6.16 joules, because it's energy. I would give you 1 mark for that, half mark for that, half mark for the answer. This one, you don't need as much kinetic energy because you don't need to go as fast. So why don't we just put all of our satellites way out there? If I didn't ask you to calculate, but if you calculate how much potential energy that took, it took an awful lot because you had to really get it far from the Earth. So it's a trade-off. Satellite orbits the Earth. We're in orbit with a period of that. What's the satellite's orbital radius? Well, again, gravity is what's pulling me in a circle. Big G, big M, little m over r squared equals m4 pi squared r over t. Don't forget the squared. Yay. I think the r squared is going to move there. It's going to become an r cubed. The r does not cancel this time. In fact, I think we're going to get this. T squared equals 4 pi squared r cubed all over big G, big M. Is that right? How to get rid of a squared. Okay. By the way, I guess for what it's worth, I could also, if I gave you the period and the radius, you could find the mass of the planet. There's another thing. Is that wrong? Oh, I want to get the r by itself. Why am I getting the t by itself? Is that what you're saying? Oh, this is cool. We get to do the cube root, Raj. How could I have missed that? I get to cube root. Before I go further, though, Raj, for what it's worth, I've said to you if I give you any of r or t or v, it's the I guess also if I give you the radius and the period, I could ask you to find the mass of the planet. Get the big M by itself. Which, you know what? They might use that if they're observing some of the smaller satellites in our solar system around different planets, because the little m would cancel, and it'd be very easy to measure the radius. That's an observational, and it'd be very easy to time the period. I wonder if that's how they figured out the mass of things like Neptune and Uranus and things like that. Maybe that is. I don't know. Raj, you're saying I want to get the r cubed by itself, which means it's going to be big G, big M, t squared over 4 pi squared. And then how to get rid of a cubed? Cube root. Wow, I don't know how I botched that, but apparently I did. So it's going to be the cube root of 6.67 times 10 to the negative 11. Mass of the Earth, T. Boy, Mr. Dewick, you're running out of room here. Well, just go off the margin. 2.4 times 10 to the 4th squared all over 4 pi squared. Alrighty, here. 6.67 times 10 to the negative 11. 5.98 times 10 to the 24th. 2.4 times 10 to the 4th squared. I think I can do that on this calculator. Divided by bracket 4 times pi. I think I can square it on this calculator. Let's find out. Will I get an error? Cube root. Where the heck? Oh, this has a cube root button. There it is. Do you get that? No, yeah? 1 point, you know what? I was going to say, I guess that 9 is going to get rounded up, become a 0, and that 7 is going to become an 8. So it's going to be 1.8 times 10 to the 1, 2, 3, 4, 5, 6, 7. Meters. What if instead of saying find the radius, what if I had said find the satellite's orbital altitude? What would I do now if I wanted to find the altitude? So we've just found that distance? What if I wanted to find that distance? We just subtract the radius of the Earth, not divide. No, it's a fluke that it looks like you could divide by, but subtract the radius of the Earth, and I could find the altitude. I can't remember if I do that on the test. I think maybe in the multiple choice question I did, because my brain just twigged on that, and usually that means I thought of it but once before. I don't know. B, what's the gravitational potential energy of this satellite? Okay, potential energy is going to be big G, big M, little m over r, but negative, and not an r squared. Negative 6.67 times 10 to the negative 11. Big M. Oh, 5.9. Good gosh, Duke. 5.98 times 10 to the 24th. I was blanking there. I need little m, 1200. Divided by 1.80 times 10 to the 7th. Although, Amelia, I'm going to use my answer button, I think. Negative 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th times 1200 divided by, divided by answer button. Do you get negative 2.66 times 10 to the 10th? Joules? If you got that 3 out of 3, also if whatever radius that you got, if you dropped it down here and you went negative 6.67 times 10 to the 11 times 5.98 times 10 to the 24th times 1200 divided by whatever answer you had, I'll give you a full here. For 3 marks, I guess, I don't know why I made this 3 marks, but okay. 1, 1, 1, I guess. Oh, for 2A? That's a good question. For 2 marks, I'd probably give you, again, a half mark for knowing the starting point. I'd probably give you a half mark if I saw that with the cube root. I'd probably give you a half mark for the numbers and a half mark for the answer, I guess. Is that okay? You make a mistake? Cube root, I'm guessing. No? Okay, yeah. Or, honestly, I've done this all the time. I think cube root, but out of habit, my hand hit the square root button because that's the one that I've hit so often that my brain just goes there. That never happens. Some of you are brain. Okay. Lifted. Does this question say that we're put in orbit? Kyle, does this question say that we're put in orbit? No, just lifted. So I'm going to start out how much work. I'm going to say work equals change in potential plus change in kinetic. But in this case, I can do that. As compared to number 5, since we're in orbit, and number 6, since we're in orbit, but here, since we're just lifting, yay. What's changing anything? This is going to be negative big G, big M, little m all over R final minus negative big G, big M, little m all over R initial. I think R initial is going to be our Earth. Yay. Ooh. The final R is going to be 4.6 times 10 to the 5th plus 6.38 times 10 to the 6th because they gave me the altitude. All they gave me was that distance. I better add the radius of the Earth as well. So R is going to be .84 times 10 to the 6th meters. Okay, I think I'm ready to go. Negative 6.67 times 10 to the negative 11. 5.98 times 10 to the 24th. 6,450 6.84 times 10 to the 6th plus same thing times same thing times same thing. Hey, Kyle, what do I call those little quotation marks in this situation? Learned something new today. Could you do this all at once in one? You could, but because so much of the typing is repetitive, I tend to break this into 2 steps, write each answer down to like 5 sig figs, and then add them up. So I'm going to go like this. Negative 6.67 negative 11 times 5.98 24 times 6450 divided by 6.84. I get negative 3.7612 times 10 to the 11th plus, on these I think it's just back, yeah, it's back arrow, so delete, and it's 6.38. 4.0324 times 10 to the 11th. Plus negative 3.7612 times 10 to the 11th. Do you get 2.71 times 10 to the 10th? Uh-oh. Yes? Yeah? So if you got that, 3 out of 3. Otherwise, I guess I would give you a half mark for finding the radius, cluing in that it was an altitude that I gave you. Sneaky me, Mr. Duick, and finding the radius. I would give you a half mark if I saw that. I would give you a half mark if I saw this. I would give you a half mark for the numbers. I would give you a half mark for those, and a half mark for the answer. Please tell me that adds to 3. I think it does. But if you got the right answer, 3 out of 3. I would take, because this is so much typing, Alex, I would take some leeway. 2.70, I'd probably accept. 2.72, I'd probably accept. I'd probably accept almost anything that was 2.7 something, as long as it wasn't 2.75 and should get rounded up or something like that. Lots of typing. Clay, what's number 4 want me to find?
How fast is traveling?
Oh, it's not asking me to find how much work? No. Oh. This is a job for kinetic conservation of energy, sorry. KE initial plus PE initial equals KE final plus PE final. Clay, are we starting in outer space? Say yes. Yep. Yeah, then I can't use MGH. Although I can do this, yay! Because it does say falls from rest. Now understand this is kind of garbage because satellites can't be at rest. If they're satellites, they have to be moving. But you know what? Let's pretend it fired its retro rockets and brought itself to a dead stop up there and then came crashing back down. There's our little thought experiment. By the way, this is why, because I think the answer we're going to get is pretty fast, and that's from rest. Asteroids that hit the Earth, do they come into the Earth from rest, or are they already moving pretty fast as they're coming into the Earth? Yeah, this is why, I mean, 2 words, dinosaurs, right? It's going to do some damage. Like the one that's going to hit us in 2036. I didn't tell you this? Put your pencils down. That was depressing, Mr. Duick. Then my work here is done. Here we go! Now, so we looked at Apophis, the asteroid. Here, this one's starting at rest. The one that you just learned about, it's not starting at rest. It's got plenty of kinetic energy. This is going to be negative big G, big M, little m, all over R. Do you save that video just for this quiz? Maybe. R initial is going to be outer space, not Earth. And that's going to equal a half m v final squared plus negative big G, big M, little m, all over. And this time, our final is our Earth. Right? By the way, the reason I write our Earth is I don't want to get initial and final mixed up, and I want to make sure I put the Earth in the right place. You could put our final just fine. I want to find this. Trust me, getting the V by itself, not worth it. What I'm going to do is I'm going to plus this to that side, get an answer over on the left, and then get the V by itself. I'm going to go negative big G, big M, little m, all over R initial, plus big G, big M, little m, all over R final. That equals a half M V final squared. Oh, I do notice that. Yay! Clay, you going to make it? Because there's some mighty long blinks. Okay. Negative 6.67 times 10 to the negative 11. 5.98 times 10 to the 24th. All over 6.6 times 10 to the 7th. Is that correct? It's not correct. That's the height. I'm going to have to add the Earth's radius. Here I did it separately on a separate line. Here I chose to do it in the equation. Mitchell, I don't care which method that you use, but just make sure you notice words like height, altitude, and radius. Radius is the easiest, yay! But typically we give heights. Plus, same thing, times same thing. Hey, Kyle, what do I call those little vertical lines? Those little quotation marks. Well, that's kind of cool. 6.38 times 10 to the 6th. That equals a half. Oh, the m canceled, didn't it? V squared. I got room? Oh, please. Whew. Negative 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th divided by bracket 6.67, scientific notation button 7, plus 6.38. Psst. A little quieter, Josh. Thank you, guys. Times 10 to the 6th. Double check my typing. Looks good. So my initial potential energy is negative 55. You know what? I'm just going to write negative 5510721. Negative 5510721 plus, did I get that right? 5510721? Sure. 0.1. I don't care about the decimals. That's not going to make a difference. And then I think I'm just going to go delete, 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 delete. Oh, but I wanted that to be a plus. I forgot to delete the negative. Ha! Times negative 1. There, now it's a plus. Wasn't that clever? 6251818 6251818 That equals 0.5 v squared. Now I'm home free. I'm going to add negative 5510721. That gives me that. How would I get the v by itself? What will I do with the 0.5? Divide it, or I could times by 2, same thing. I'll go divide by 0.5. And then how to get rid of a squared? It's a lot of work. It's rocket science. Do you get 10,670? I'll go 10,700. So that thing's going to be coming in at about just shy of 11 kilometers a second. It'll be hauling. Now, I'm ignoring air resistance. Coming in that fast, I guarantee it would start burning up when it hits the atmosphere. There would be air resistance, but that's beyond our ability to deal with the math that we have right now. If you got that, what did I make this worth? 3 out of 3? Otherwise, wow, do it. I would give you a half mark if I saw that. Would give you a half mark if I saw that. I guess I would give you a half mark for cluing in it was conservation of energy. Yeah, I would give you a half mark for that, a half mark for that, and a half mark for the answer. And I think that's 3 halves. 6 halves. It's 3 marks. Whoo! Woo! Turn the page. Jason, what word did I underline? Moon. I better make sure I use the correct mass. Okay? If you use 5.98 times 10 to the 24th, sorry. Mr. Dewick says to do this, find the change in potential, which is going to be negative big G, big M, little m over R final minus negative big G, big M, little m over R initial, which is going to be negative big G. Mass of the moon. I have no... Oh, I got a sheet here. Mass of the moon is 7.35 times 10 to the 22nd. Mass of the satellite. All over. R final. Did they give me the radius or did they give me a height in this question? Oh, so it's going to be 2 times 10 to the 6th plus the radius of the moon, 1.74 times 10 to the 6th. Plus, same thing times same thing times same thing divided by 1.74 times 10 to the 6th. Whew! Lots of work for one question, no pun intended. Negative 6.67 times 10 to the negative 11 times 7.35 times 10 to the 22 times 1600 divided by bracket 2 times 10 to the 6th plus 1.74 times 10 to the 6th. That negative 4.456. How about negative 4.4568? Negative 4.4568 times 10 to the 1, 2, 3, 4, 5, 6, 7. Mr. Dewick, I thought you said these would always be in the times 10 to the 10th or 10 to the 11th or 10 to the 9th range. Hey, we're around the moon. It takes less work, which is one of the reasons it'd be nice to build a moon base and launch stuff from there. Way easier. Plus, don't forget to delete the negative this time, Mr. Dewick. And I need to delete... Oh, hang on. This is totally wrong. I missed a decimal. Arg! Jeez. Negative. This is garbage. Sorry, guys. That's what I want. Well, that's going to give me a better answer. Did you get 2.0973 times... So negative 2.09... Is that right? Times 10 to the... Sorry, folks. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 seems better. That 7 seemed a little small to me, which is why I mentioned it. Okay. Now, backspace. Delete the negative. And I can delete the 2 times 10 to the 6th. Oh! 4.508 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus negative 2.0973 times 10 to the 9th. So my change in potential, 2.4107 times 10 to the 9th. I'll come back to that. My change in kinetic, it's going to be KE final minus KE initial. I think, Josh, I said that we're starting out at rest stationary. I think I said that in the question, did I not? So it's going to be a half mv squared. It's going to be a half times 1600. I think I gave you the orbital speed, did I not? 1.15 times 10 to the 3. My change in kinetic, 0.5 times 1600 times 1.15 times 10 to the 3rd squared. 1.058 times 1, 2, 3, 4, 5, 6, 7, 8. 1.058 times 10 to the 9th. Joules. Final answer. It's going to be the change in potential, which was 2.4017 times 10 to the 9th plus 1.058 times 10 to the 9th. Still significantly cheaper than launching from Earth. 2.4017 times 10 to the 9th plus, haha, answer button. Do you get 3.46 times 10 to the 9th? Is that right? People are nodding. I'd take 3.45. I'd take 3.47. 3.4 something. Is that the longest question of the year? Nope. Second longest. Longest question of the year is, hey, what if I don't give you the orbital radius? Sorry, the orbital speed, and you calculate it? Like number 6. Oh, what's going to be the part marks? How many marks is this worth? I'm going to be really wimpy here, and I apologize, Spencer, but I'm going to say, how about 1 mark if you found that, 1 mark if you found that, and 1 mark if you added them up? But that's a nice way. To be honest, this question on your test is worth 7 marks, and I do give out lots and lots and lots of part marks. But on a quiz, I'll be a bit fussier, especially knowing that you can always redo the quiz and get your part marks. What'd you do? Just zigged on what?
Oh, I mistaken I didn't add the 1.74.
Yeah, there you go. I'll give you a 2.5 out of 3.
Okay.
That, to me, that would be a half mark. And what I would do on the test, I would have crunched it for people and gotten an answer if people missed that. And at the bottom of my answer key, it would have said something like 6 out of 7 if they missed that this is an altitude, not a radius. And I would have run the numbers there. Yeah.
Mr. Dewey, I kind of messed up on the same question and just only I put the mass of the Earth instead of the moon.
Oops. So I would give you 2.5 out of 3. I think you would have... Oof, no. I could actually calculate your answer. Yeah, sure. Because the mass of the... No, never mind. The mass of the moon is not on every factor. I take that back. I thought I could change that very easily into a mass of the Earth answer, but I can't. Last one. First of all, did they give me an altitude or did they give me a radius? Oh, thank God. At least that's a little less work. We're around the Earth. Change in potential is going to be negative big G, big M, little m over R final, which is R orbit, minus negative big G, big M, little m all over R initial, which is R Earth. You okay with that, Dustin? Oh, there's a lot of typing. Okay. It's going to be negative 6.67 times 10 to the negative 11. 5.98 times 10 to the 24th. 3,200. All divided by 8.3 times 10 to the 7th. That's pretty far out there. Because plus, same thing, same thing, same thing, divided by 6.38 times 10 to the 6th. By the way, if you realize when NASA did the moon thing, they did it before calculators. They were doing the math by hand using slide rules and by hand doing all this stuff. How many of you have seen the movie Apollo 13? There's a great scene in there where Tom Hanks, the astronaut, has run his new orbit numbers and he asks the NASA people back home to check his math, and he just reads out his answers, and there's like 50 people running the numbers by hand because nobody had calculators, and they're pulling their slide. You get the same answer. You got 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 the same answer. Okay, I think we're good with those. That's how they did it. You have far more computing power in your calculator than they had in the Apollo spaceships that they sent to the moon. Far more. They really did that with some very clever engineering. I think it's a hoax. No, they did go there. I've got a brother who's a moon landing denier. Learn physics. Dope, dope, dope. I think that's right. Double check this time for typos, Mr. Dewick. Negative 1.5378 times 10 to the 10th. Backspace. Delete the negative. 6.38 times 10, 6.38 times 10 to the 6th. 2.0006 times 10, 2.0006. Alrighty, here we go. Takeaway 1.5378 times 10 to the 10th. Do you got a change in potential of 1.8468 times 10 to the 11th? Yeah? Yeah. 1.8468 times, is that right?
Yeah.
1.8468 times 1.8468 times 10 to the 10th, Mr. Dewick? 11th, I think it was. Joules. There's how much I need just to get up there. How much do I need to stay up there? It's going to be a half m v final squared. Oh, I think it said starts at rest, so my initial kinetic energy is 0. In fact, really, this v final is going to be v orb. Did they tell me what my orbital speed is? No? Well, then to you I say, gravity is what's pulling me in a circle. Big G, big M, little m over r squared equals mv squared over r. Mass cancels, r cancels, and although I could square root because I think I'm just going to plug this in for the v squared, cleverly, and I'm going to get this. The change in kinetic energy is going to be a half little m, big G, big M over r orb, which is going to be a half little m, Mr. Dewick was 3,200. 6.67 times 10 to the negative 11. 5.98 times 10 to the 24th. All over our orb, 8.3 times 10 to the 7th. Is that okay, Dale?
Yep.
I'm going to be clever. Dale, oh no, I can't. Maybe I can be clever. How do I replay on this thing, Mr. Dewick? I really don't want to is it shift up arrow? Shift up arrow? There is a way to shift that. How do I get back 2 lines? Clay, you use this calculator. Is there a way to get back 2 lines?
No,
There is. I know I've done it before, but I can't remember. I gotta retype it. Son of a gun. 0.5 times 3,200 times 6.67 times 5.98, 24 divided by 8.3. Okay. Consider it retyped. 7.6890, 7.6890, 7.6890 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? Is that what you got for the change in kinetic? Work is going to be the change in potential. 1.8468 times 10 to the 11th plus 7.689 times 10 to the 9th equals 1.8468 times 10 to the 11th. Please tell me you got 1.92 times 10 to the 11th joules. Wow. How would you give up part marks there, Mr. Dewick? Oh, I made this one 7 marks, did I? I would probably go something like this. I would give you 1 whole mark because that's the key. I would give you a half mark if I saw that. I would give you 1 whole mark for finding that. That gives you 2.5 out of 7. I would give you, Mr. Dewick, 1 mark if I saw that. I would give you 1 mark if I saw that. That's 4.5 out of 7. I would give you 1 mark for that. That's 5.5 out of 7. I would give you 1 mark for that. That's 6.5 out of 7. And I'd give you a half mark for cluing in that you had to. I'd do something like that. I don't know. I can't remember. Holy smokes. Could you give yourself, please, a lovely score on this quiz out of 25?